I'm Albert Ossó. I'm a PhD student in the University of Barcelona, and I am regularly collaborating with Professor Dave Thompson in the Colorado State University. So I'm going to present the work I've been doing during my stage in Colorado. The title is The Mystery of Recent Stratospheric Temperature Trends. Well, our idea was to use the stratosphere as a laboratory for climate change detection, and that it's possible because the stratosphere has a lower natural variability, and well, this natural lower variability helps us to detect climate change and to distinguish between the climate responses to natural and to anthropogenic climate forcings. Just to note that the relative effects of the greenhouse gas released in the stratosphere is cooling the stratosphere, not warming like in the troposphere. The problem that we found in the stratosphere is that the data records are very sparse and come only from a handful of data sources, that most of them are only available for a satellite era. So here I have some examples of, data sets. This is the stratospheric sounding unit, microwave sounding units, and the advanced microwave sounding unit that are only the sources of data that have global coverage and enough time extension to be useful for trend analysis and detection. Well, our aim was to make an update of the stratosphere temperature trends. But our surprise was that when we analyzed the new released data set from the North Star group in Washington, we have found that this new data set provides a strikingly different picture of the stratospheric climate change, comparing with the previous data sets, and call us into question our basic understanding of stratosphere temperature trends and to our ability to test simulations of these changes. So here in this last plot, let me see if I can. All right. So here, this is the global mean time series for different stratosphere altitudes. This is lower stratosphere. These two channels are medium stratosphere and high top stratosphere. This is the global mean from 79 to 2010, more or less. And here you can see, in red, this is the new data set. And in blue, we have the old data set that was produced for scientists in Met Office. And you can see how this new data set have a cooling trend that almost double the previous one. So our question is, what's really going on here? Which is the correct data set? It's the previous one, it's the new one. So we test some models. Here we have some chemistry climate models, and here's also global means. And you can see that these models doesn't really help us a lot to choose between these two data sets, because the models, depending on the level, tells us different histories. And this is the new models, that the CME5 model that has been used for the studies for the new IPCC report. And you can see that indeed that these models are not well prepared to work in the stratosphere. You can see that they are telling a very similar story like chemistry and climate models. So, well, that's what is happening now in the stratosphere, and we have been working on that problem to try to understand what is really going on. And, well, just say that we have just published a paper in Nature 1 month ago, so if you want to look it more carefully, you can go there and see. Okay, just that. Thank you so much.